I do want to welcome everybody here, and especially Professor Hima Lakkaraju and Professor Chris Babbitt. David Parks is somewhere in limbo land in London trying to get into Zoom. I think he's, he works at DeepMind, so maybe, it's a Google Meets / DeepMind problem that we might be facing. But let's get going, and then hopefully we can find a way to rescue David from London and join us virtually here. Hang on 1 second, please. I just gotta. Okay, so as we all know, we're living in this crazy times called generative AI, and we are basically in many ways set up to really have some extraordinary outcomes in the world of technology, in the world of business, and in many ways, from my perspective, for all of humanity. For me, this seems like a similar moment to when the browser got invented way back when. And when the browser got invented, we all got sort of aware of what it means for information to be free and freely accessible, such that even a coffee pot, at Oxford University could have its own webpage. And there's a straight line between the browser being invented 30 years ago to the world we're now in, where there's tremendous amounts of data, tremendous amounts of connectivity, and what we imagined the world to be for those that were born before the 1980s is very different than what it is right now. And my sense is that with generative AI, the same kind of issues are in front of us, where now our ability to have sort of cognitive capabilities at zero marginal cost has greatly increased, and that is causing everybody to sort of reimagine what the world ahead with us will be. So I've got two great colleagues here, and then David Parks is texting me. Maybe I can bring him in by my phone or something. We'll figure that out. So maybe I'll channel David Parks through my text messages, but I have Professor Hima Lakkaraju, who's at the Harvard Business School and also at the engineering school, and Professor Chris Babbitt from the law school for the conversation. And I want to start the discussion, and let me just spotlight Hima and Chris here. And somebody can spotlight me so people can see me as well. That'd be great. Awesome. Okay, great. For us to begin the conversation. So Hima, let's start with you, since you're deep in this world. You're writing papers on this, you're in the face of it. Maybe give us a sense of why now, why this crazy world has emerged right now. And why is everybody, especially in the computer science world, so taken by surprise by what we've seen around ChatGPT, but all the other generative models that exist?
Right. So I think, of course, while it's, everything can be explained a lot more nicely and beautifully in retrospect than being able to predict it, I'm going to try and make that attempt here, right? So when we look back from this point where we are today and, over the last decade or so, it's not entirely surprising to see where we are today. The reason why I make that statement is because, let's say if we were to talk about sort of early 2010 and so on, or even, 2008, so this revolution of deep learning started becoming a bigger thing in the literature of computer science, machine learning, and so on. The reason being that these algorithms existed since 80s, 90s, right? So the algorithms to sort of learn neural networks, but in order to operate them properly, we needed both data and also compute and scale. Right. So I think those two things sort of came together close to 2005 to 2008. And we saw about 5 to 6 years of like complete deep learning revolution where, deep learning models were beating benchmarks and text-based tasks, vision-based tasks, all kinds of things. And then I think, fast forward a decade from then, more and more algorithms and tools were developed. We also improved our ability to compute things at scale, and we got more and more data. So it's not surprising that all of this is converging in almost sort of a superhuman-like capability of being able to, do several tasks with single models with like some small amounts of fine tuning and so on, right? So I think if we look back, it's not that surprising, but I think what took the machine learning and computer science world by surprise is more of these models being released by industry and like them beating each other in like different tasks, like, like almost like sort of a domino effect, right? I think that progress and the rate at which it happened in the last 2-3 years, the growth has been exponential in terms of tooling. The techniques always existed, but like bringing them together in terms of tooling, I think people didn't expect that to happen just within a span of like a couple of years, one after the other.
Fabulous. And so, Hema, were you surprised with how effective ChatGPT is?
That's a good question. I think there are parts of it that do take me by surprise, but there are also parts of it that make me feel like, oh, this is just terrible at this task, right? So
Okay, so tell me what parts surprise you.
Yeah, the parts that surprise me is how a singular model can answer questions about like such a diverse set of things, right? So you can talk about some of the medical information related things and it's giving you answers that seem reasonable. You can use it to write emails, you can use it to do several other things. So it's not a domain specific model anymore. It almost gives an impression of being omniscient. That said, there are some simple tasks where it was just kind of breaking apart, which is especially when it comes to like, references in literature and so on in different fields. Sometimes you just see it making up stuff. And, that is like, you can just see how terrible it is just on the surface.
Yeah, great. And we have good news. My good friend David Parks is here as well. Hello, David. Great to see you here.
So happy to be here.
We will just blame the fact that you're working at DeepMind and like Zoom or something for you not being able to get in for now. David, let me ask you the same question I asked Hema. Are you surprised by this ChatGPT stuff, and why now?
I'm also seeing a lot of latency on my connection, Kareem. Am I okay?
Yeah, I can hear you. So you just keep going. Your video, maybe turn your video off, and then we can just hear you.
Yeah,
there you go.
I absolutely shocked. I mean, this like the pace with which we've seen change. I think nobody in the field of AI would have expected. The technical ideas are not super new. They go back to 2017, but it's really a question of scale. And I don't think that anybody realized that, well, first of all, how quickly we'd be able to scale these models. And secondly, how much of an effect that scale would have. Everybody's talking about the emergent properties. These are things that through prompting, for example, which I'm sure we'll talk about, that we hadn't really anticipated. So yes, I'm very surprised. I think there's going to be a lot of disruption.
And then David, why now? Like why like in 2022, 2023 did this all come together? Like what you as being so deep in AI, both from a scholarly point of view, but also from a practitioner point of view, like what explanation would you give to people about like why now?
Yeah, great question. I think we've been working now with deep learning models for over a decade, and it's taken that length of time to really kind of develop the engineering know-how and expertise to be able to take them to a scale where they can consume approaching a lot of the high quality language that's ever been generated. And that together with Moore's law together with uh, architectures for chips that have been able to specialize to the purpose. I mean, it's a confluence of things. It's all the digital data that mankind has created. We happen to have enough digital language data now that we can get these things to train at this scale. So it's a confluence of things. It's at least all of the things that I just pointed to.
Fabulous. Chris, how about you? What's been your experience over the last 6 months? Chris, we did a course together in September when we were sort of talking about this stuff, but it wasn't real yet. Like it felt like it was years away. And then certainly in October, November, stuff started to go crazy. So Chris, what has surprised you about large language models and generative AI?
It's a great question. It's sort of, as you were teeing up the issue and sort of comparing this moment to sort of the advent of the internet, I sort of felt like, oh, geez, again, here comes the lawyer to come in and throw cold water on some of this stuff, and particularly on some of the IP issues, because I think there's some really interesting sort of open questions out there that we can address. I guess on here on the law school campus, we've been talking about maybe two major buckets of issues. One is about legal risk, legal liability, and how do we regulate this stuff? And then the second is using law and the practice of law as a case study for application of these tools. How is this going to impact the practice of law? I'm teaching students right now who are going to be graduating from this institution in 2 months and are going to go into a world where there are tools that can, when I graduated law school 25 years ago and had to draft a legal research memo or a legal brief to file with a court, I used technology to facilitate my research, but the sort of the fundamental analytical aspects of law practice, the fundamental, here is a set of key facts, and now apply the law to those facts and assess my risk or make an argument as to the outcome of this case. I think all of that, it has the potential to be pretty radically transformed by these generative technologies. And we're at a moment where I think we need to think and think really quickly about what we're going to tell students here. Do we encourage them to use these tools and teach them how to use them responsibly and well and augment them in the practice of law? Do we banish them for the time being and say, no, this is sort of, our exams are closed book exams and go into law practice, assuming it's going to be closed book law practice for the time being. So that's one big set of issues. On that legal and regulatory point, I'll just say two things, and we can go deeper on any of this if you'd like. One is there's the same bucket of issues that we face with a whole broad range of technologies that rely on, what I'll really broadly call sort of black box algorithms. Are they fair? Are they correct? Have we trained them on a diverse enough range of data that they're producing outcomes that are equitable and reasonable and broadly applicable? And then maybe most importantly, who's liable in the chain in the event that this tool produces a harmful outcome, right? If my self-driving car has an accident, or if an algorithmic risk assessment tool used in a court system produces a risk score for a criminal defendant that is unjust, we have to think about who in the line of from the user to the producer bears some legal responsibility for that. I think the same is true for these tools. What if it produces outcomes that are, or provides information that is wrong or somehow harmful? And then the last piece, which is where I started, which is just IP, and a lot of people are writing and thinking about this now, but like the internet itself, when it started, copyrightable content is the engine that drives these tools. Largely, huge swaths of text, but also images, audiovisual materials. My background is in music law. I used to work in the music industry. There are amazing tools now that are ingesting musical compositions and sound recordings to produce new musical compositions and sound recordings. What are the IP implications of that, both at the input end, right? Are we copying lots of copyrightable content in order to train these tools? And at the output end, what if it produces a body of text or a piece of music or an image that itself infringes or is substantially similar to an existing piece of music or text or image? So I think there's questions about the application here to law practice. I think there's broad questions about the use of sort of AI and algorithmic tools. And then I think there's these particular IP questions that are really, really rich.
Fabulous, Chris. And so, Chris, and I'm going to put this to everybody because I'm facing this question myself. So I'll just be totally honest. I'm writing a paper with a colleague, and we were stuck on a few pages. Put it into ChatGPT and say, "Can you simplify this for us?" And it did a beautiful simplification. took our abstract and said, can you simplify the abstract? Beautiful. Can you generate 5 titles for me? Like, am I cheating? Like, am I like, and so like, I felt like dirty and like, am I cheating? What's going on? Like I was myself sort of, sort of in this mode of like, what's going on in this world? And, I was in a session a couple of weeks ago with about 25 CIOs, and they all said, well, we're stopping our people from using generative AI because of IP considerations and so forth. And I said, now with this thing, I don't need your permission. I can use large language models on my personal phone. And you were worried about shadow IT. Now there's shadow AI. Like, and how will you police that, and how will you stop it? And so it's causing sort of foundational questions of what it, at least for me, what it means to be a thinking human being, and should you not use it to help you do your work? And so I want to take that question, what Chris asked about, what do we teach law students, what do we advise lawyers, and back to David and Fahima. So like, if you sort of think about, even when you're teaching now programming, when you're teaching statistics, do you prevent your students from using a large language model to debug their R code or to generate the R code or not? Like, what do you guys think about that as a way to, to make this a real problem? Because this question is, every company is facing this question of saying like, okay, this is so bloody good, should we not use it? And why would we stop ourselves? So would love Hima and David to give a perspective, and I'd love our lawyer friend to say, you're all going to court and you're all going to jail.
I can start maybe. Yeah. So that's actually a very interesting question. And one thing you pointed out, Karim, as you were discussing this, was it's making us all question what it means to be like a thinking human being, right? So what exactly is our contribution now that ChatGPT is going to write things for us, write code for us, we can use it to a good degree in all of these. So I just want to start by saying, so that Chris does not come after me legally, that so far in our classes, there are no, ChatGPT or any kind of language models are not allowed either for coding or for writing. But that said, what do we do going forward is a question that has been on my mind quite a bit. I think, to be very honest with you, I actually feel kind of, being stuck in this tension of, one is saying that, thinking and writing are things that academics are supposed to train students to do, right? So in that case, that's a skill that they need to develop, because of which we'll ask them not to use these kinds of tools. That's one side of it. The other side of it is, well, at some point, maybe computers were also new, and then we weren't supposed to use them, but then they seeped into like the normal culture and people started using more of them, and now we can make a lot of things efficient. So maybe is the way to go to coexist with them, benefit from them, and then do the jobs we were doing earlier in a more efficient way, in a better way. So I often kind of keep giving myself arguments for both sides, to be very honest with you. I don't know if I have like converged on one side, but I think as someone who believes a bit in the promise of tech generally, I feel some kind of like slow adaptation or sort of slow inclusion of these kinds of technologies, bit by bit, step by step, so that we are benefiting from them, and then eventually.
But Hima, do we have any choice to go bit by bit and step by step? My sense is that we've made this step change, and there's no more sort of a linear path. Like we wish we could go step by step and bit by bit, but it's kind of like, I just got an invitation from Google to be on the wait list for Bard, right? I have through Poe.com access to, Claude and GPT-4, right?
Yeah.
On my smartphone, right? I'm now using this to answer a whole bunch of questions for me. And so I'm just trying to think, like, are we just in dreamland, Hima, that like we're going to go bit by bit, step by step, when in fact, the tech companies have basically pushed this out, and not just tech companies, 100 million people have said, I want to use this thing.
So the reason why, when I say step by step, let me explain at least how I was thinking about it. Again, not a foolproof strategy, but for example, in courses and so on, maybe we can start with letting students take help of some of the writing aspects, but then maybe we say like coding is something that you need to do on your own, and then slowly build it up, right? Irrespective of what progress is there externally, so that we really can like understand what's going on. The reason why I say that's important is, I'm going to say, bring up a point which I've often seen when it comes to developing new models in machine learning, right? So a lot of times the sort of ideology or the thinking behind it is, let's sort of get these models, build more complex models and keep building. And then once they are out, we are going to examine their implications on the society. We are going to understand whether they're fair and, preserving privacy properties of data and so on, and then fix whatever consequences are happening because of that, right? I think even now we are at that stage where we have a bunch of models thrown at us, new kinds of tools and techniques, and now we are just kind of figuring it out. Oh, is this good? Is this bad? Like, what are the implications for, economic aspects of the society? Are these models like causing biases? Again, nobody has like very good understanding of all these. So given that, at least in, domains where we can control and do things step by step, that could just be like maybe academic exams, right? It might be better to think carefully about their implications and do it bit by bit, but yeah.
That was David.
Yeah, really great question. Let me go off the video again. So I'm not going to talk to what I think Chris will talk to, except very tangentially. I do want to say that I'm an editor on Archive, and Archive has a policy about how tools like ChatGPT can be used. And I just checked the policies. Let me tell you high level what the policy is. First of all, ChatGPT cannot be an author of a research paper. And so a human has to be an author. Archive reasons that a human has to be an author because it needs a human, this is getting a little bit into the legal realm now, to take responsibility for the contents of the paper. So first of all, I have to be the author, not ChatGPT. Secondly, the implication of that is that when I sign as an author on a paper, I take responsibility for the contents of the paper. I take responsibility for no plagiarized content, no errors, mistakes, no misleading content, etc. So like the things that I'm always expected to do as an academic, I take responsibility for. Thirdly, I need to record the tools I use when I write my paper. So I think that I feel very comfortable with those guidelines. And then let me just add in regard to coding. These are incredible new tools. I think that's the right way to think about it. I think they're amplifiers. And coding is going to be incredibly more efficient and incredibly more powerful by using these tools. Yes, that does at the same time present both a big challenge for education, because now clearly we have to find new ways to teach people how to code with these tools. So we have to retool as educators so we can teach people what they need to know about how to use these tools. And secondly, the pace of change is going to be the real challenge here. It's incredible, and it's going to be very hard for lots of parts of society to respond, including the academic sector, in regard to how do we teach.
Yeah, and George Westerman, hi George, I just put a nice comment in the chat saying professors in English comp classes are now asking the students to generate their first draft with GPT and submit both first draft and edited final with an explanation of why they made the changes. Still teaches and tests principles of good writing while recognizing the existence of the technology itself. So again, we're seeing this sort of emerge in many settings. Chris, what's your sense on this?
Yeah, that comment on teaching English comp is really interesting. I was thinking about it, and I love the juxtaposition with David's thoughts on this in the context of coding. Thinking about it from the perspective of law practice, if I were a baby lawyer at a law firm and a client came in and had been sued for a particular, for breach of contract in Massachusetts, and my law firm was going to take it on and say, we're going to make an early stage motion in court to get rid of this case, it would be malpractice for me not to look at previous examples of motions to dismiss breach of contract claims in Massachusetts. That's what lawyers do, right? The same way, if we started a brand new startup that was a social media video sharing startup, and we needed to draft our terms of use and our our user agreements and that sort of thing, it would be malpractice for us probably not to look at something like YouTube, which exists. And I've been thinking about this for a while. We shouldn't copy that wholesale, but it would be interesting and probably useful for us to look at that, as well as at other examples and samples and form licenses and that sort of thing. So I think in law practice, or like in coding, there are you ask a question, sort of what is cheating? There are, professional norms and customs and ethics. There are professional codes of responsibility that govern us in law and certainly in medicine and some other professions. There are norms around attribution. And I think that those will have to evolve to keep up with this, just as norms and customs around use of form agreements and templates and that kind of thing have evolved. On Kareem's point about sort of the pace at which this is going, it's been mind-blowing to me as someone who's thinks about the legal and regulatory issues, but much less the technological issues. It was reported back in December or January that GPT 3.5 had come close but not quite past a bar exam. And a bar exam, to be clear, includes a lot of multiple choice or factual questions. What is the statute of limitations on this, cause of action, that sort of thing. And also a lot of essays where you do analysis. You take a set of facts and you apply. And GPT 3.5 got, I think, a 50% score against a passing rate of 68%. And GPT-4 last week, it was reported scored higher than the average, would pass the uniform bar exam, and would have placed in the 90th percentile. This is according to a paper out of Illinois Tech. So, I mean, that's a matter of a couple months. So as Kareem said, last September, October, November, we were thinking about this stuff. December, January, it's out, and we're thinking about the ramifications. And then with GPT-4, just in the last few days, the pace has just been extraordinary.
And here's the thing that is sort of, again, as I put on my closet historian hat on, right? I still remember the dial-up days, and then the pots, like the cable internet and then fiber and all this kind of stuff, to now where, doing a Zoom call on this while I'm walking the streets of Boston is like you don't think twice about it. Like you think you can do a Zoom call on your mobile phone while you're walking around the city, almost anywhere in the world almost. And I wonder to David and Hema, maybe started with David first, like it feels like the pace is going to accelerate. The models are getting more compact. The GPU needs the data is expanding exponentially. The models are getting more compact. The GPU burdens keep dropping. Different architectures are being created and so forth. So where do you sort of foresee like this pace of change? And many companies are entering and trying to make sense of this. So what's your sense of the pace of change that we're sort of in the middle of?
Great question. And I think it is the pace of change that is so daunting. One thing that people might want to know about is there are scaling laws that are being developed for these very large models. I'm sure everybody's heard of Moore's law. Roughly talks about the pace at which we can double our computational capacity. There are scaling laws now. So we have technical roadmaps for these large language models. Roughly, if you look at these papers, think about the x-axis being on a logarithmic scale. And that's representing the size of the model, whether you measure the number of parameters in the model or the amount of data it was trained on. So there's a logarithmic x scale, and then the y scale is linear. And these scaling plots are a straight line on those plots. So what does that say? That says, I mean, it's interesting, right? It says that if you 10x the scale, however you want to measure the scale, that you get a kind of linear improvement in the performance of the model measured in traditional metrics like accuracy, right? Not maybe quite the right cognitively relevant measure. So let me say that again. Kind of 10x improvement gives you a much smaller kind of linear improvement. That's not the way you'd like the scaling curve to work. You'd like it to be linear to linear. It's kind of multiply this thing by by a factor of text, you get an incremental improvement. But the significant thing, there are two significant things that come out of that. One, it's predictable. You can take a ton of models that have been trained and they all fit on this line. That's one significant thing. So we can predict what the future might look like. And the second thing is that it implies how much more computational power we're going to need to have access to be able to scale these up. One thing that I'll mention, Kareem, before I hand over to Ima, is that actually some people are predicting that the bottleneck is not going to be compute, but it's going to be data. I alluded to this earlier, but there's one paper that predicts that we'll run out of high quality data by 2026. By 2026, high quality data. Now, a potential mitigating factor is that models like GPT-4 that Chris referred to a minute or two ago are multimodal models, meaning that they can consume visual data and textual data. And so they can train one model that is somehow pulling useful information out of different types of data sources. That's a potential mitigating factor. I think I dodged the part of your question about smartphones, but let me just comment that these models at the moment are running in the cloud, not on end devices, and not only because of size and energy consumption, but also because companies want to hold on to them so that they can change them over time easily, which maybe is harder if they get pushed into the edge.
Nemo.
Yeah. Thanks, David, and agree with a lot of the thoughts that you have talked about in terms of the scale and so on. I'll try and touch upon, so where are we headed with all this? And I think, do we have any solid predictions about where this rate of progress might lead us to? And I think the honest answer is probably not. I think everyone is including, I think there is a question in the chat as well, which is, do experts also, are we still figuring out like what could be the implications of these kinds of progress, these kinds of models? Where are we going? And I think that, the answer to that question is yes. I think everybody is trying to grapple with where we are going with all of these. So it's interesting that David also mentioned that we might run out of quality data. So I think compute we are sort of on top of, but we might run out of data. There is one point that I would like to kind of try and highlight in this discussion, which is that already with the, sort of the coming out of these kinds of models, we are seeing some of the barriers exaggerate when it comes to companies having a higher control in terms of developing these models, having access to a lot more data, compute resources, and so on, right? So I think we need to think very carefully about how to sort of make these gaps smaller and not make them much more disproportionate to a point where like nobody else has access to what's going on with these models and just like, 2 to 3 companies are owning everything there. I think there is a real risk of that happening in the next few years, or maybe it's already there. And I think there is a real risk of that only exaggerating in the next few years.
Fabulous. So look, we have 7 minutes left. We started late, but I want to end on time because I want to be respectful of all 3 of you guys' time, because I know it's you guys are super busy, and I think it's bedtime almost for David here in London. Let me ask a question on explainability, hallucination specifically, and so because people always say like what do we do about hallucinations? What do we do about explainability? What do we do about accuracy? And I'm always thinking, well, what's my counterfactual, right? My counterfactual is my fellow human being, and my fellow human beings, well, if I look at myself, I'm not accurate. My explainability, like how I come up with answers, I don't know what's going on in my neurons, right? And then hallucination, I think David has some choice words for my hallucination capabilities. And so if the counterfactual is humans, what is our standard that we should be having around accuracy, around explainability, around hallucinations? And the fact that these things are generative tells us that that's their job, is to come up with new stuff. And some of the stuff is going to be hallucinations. It did a great job of hallucinating papers I should have written, cases I should have written, and give me great ideas on cases I need to go and write. But I just wanted your perspectives on how to think about these things, just as we wrap up today. And then, what I'm forecasting is that we need to have a much longer conversation with three of you again, because we're just barely scratching the surface. So Chris, maybe you want to get us going, because you're in the law school, You guys think about philosophy and morality and law and all that kind of stuff. Help us think about this hallucination, explainability, accuracy kind of question.
Well, so I'll give two sort of extreme answers to that. And this actually builds off something Hima said about sort of one risk here is that we end up with a very small concentration of a couple of very large companies that control all of this. I suppose there's a flip side risk, and someone put in the chat too, that we can all create our own models at some point. Costs are coming down. We all have access to data, some IP issues. Compute power, at least, is becoming affordable, and so we could have a huge proliferation of these things. And then the questions that Kareem asks are really important, because one answer could be, well, we'll let the market sort it out, right? If we have Lagaraju LLM and Babbitt's LLM and Lakhani LLM and Park's LLM, and we're all out there competing, and Babbitt's LLM is known for being incredibly inaccurate and hallucinating and just making a mess of things, I'll fall by the wayside, and people will go with your better products. But I think that there's enormous risk of just of leaving things up to sort of a pure market solution, and the answer then becomes, I think, some form of regulation and some form of a requirement of explainability, or some form of a mandatory disclosure to someone, whether it is an impartial auditor applying a set of agreed upon industry standards, or a government agency, the way our Food and Drug Administration thinks about regulating drugs and heart stents and pacemakers before we put them on the market. And we want to be sensitive to IP issues and all of that, but we also want to say someone ought to take a look under the hood of these things and understand why they're doing what they're doing before we sort of let them out there in the wild. So that's a very short answer to a very long question.
Amazing. Hima.
Yeah. So yes, I think Kareem, you're absolutely, it's a very interesting question, and you're right that your baseline, or at least our baseline, is supposed to be what a fellow human is. And a lot of times I think people give post hoc explanations which may or may not really reflect what the truth is, right? And sometimes consciously, sometimes without even knowing, so subconsciously. So there are all these sorts of issues that we are okay with when we think about humans, which you're considering as our baseline. But when it comes to these models, I think, traditionally, given that, because for a human, we can always put this sort of an accountability aspect on somebody who has made a decision ultimately, right? So the reason I think why we are asking for more information from these models is, if they make a mistake, then who is really accountable, right? And that's why we are like, give us more reasons, tell us more about what's going on, how you're thinking. And it's a well-known fact that by now, at least for now, these models do hallucinate, they generate content, cook up something which may not even be true, and try to give convincing arguments in order to support whatever they're generating, right? So one thing I just wanted to add in here is, these models have this beautiful capability to give a step-by-step rationale. So if you ask this model, for example, like a GPT, to say, think step by step, it will tell you like how it is coming up with an answer. And some of the work that we are doing in my group is using some post hoc probing tools to actually check if the rationales that these models are coming up with, when you ask them to reason step by step, actually correspond to the things that they're looking at when we try to probe them in a post hoc fashion mathematically, right? So I think that kind of tools will become more and more important. Otherwise, again, we can come across very realistic looking rationales and answers from these models, and we might really find ourselves kind of hard to discriminate between reality and what is being cooked up, right? So I'm just emphasizing the need for more tools that can probe the behavior of these models.
Great, thank you, David.
Great question. So the problem here, at least the way I think about the problem, is that I think humans are easily tricked by kind of very high quality, formatted, grammatically correct responses. And
yes.
Right. And so it's very easy to be seduced into the quality of these answers. And paradoxically, the more the hallucination problem goes away and the less we pay attention, the more the hallucination problem becomes a problem because we're no longer watching and catching these issues. A lot of people worried about safety. I think safety is actually easier, like providing appropriate, safe responses is easier than getting the factual responses correct. We don't have technical approaches really to address the hallucination problem, which is about facts. I know we're about out of time. Let me just close with two comments. One is that it is interesting that GPT-4, which is a larger model than anything we think has been trained before, is doing better with facts than GPT-3 or I would assume earlier OpenAI models as well. Okay, so somehow it is doing better. But at the same time, you know, just yesterday when I asked it to describe, you know, what do you know about David Parks? Well, it got my advisor's name wrong. It said my advisor was Michael Kearns, not Lylungar. It said that before it says that prior to joining Harvard, I was a faculty member at the Harvard School of Engineering and Applied Sciences, which was formerly the Harvard School of Engineering and Applied Sciences and Applied Sciences. So I think those, are illustrative of hallucination, making up facts, words that probably go together in some sense, but are just not true. And this is this grounding problem. So when AI people talk about grounding, it's this inability to be able to reason logically about the concepts that are in the sentences.
Amazing. So look, guys, we could go on for a whole day. We won't. Just for our participants, a few notes. We are going to share the recording of this session, so this will be available to everybody. We're going to be doing more of them. We're sort of doing this out of the seat of our pants, so that's why we had some issues ahead of time. And so I apologize again for the late start for us. But we feel like this is a very important side, and so with D-Cubed Institute and also with the Harvard Data Science Initiative, you know, we're running a series of these Zoom meetings, and then starting in April, we'll also be doing hybrid meetings where we'll be in the HBS classroom, but also on Zoom to really explore many aspects of this space and to really create a community of people that are interested in learning more, in doing more, but also importantly, set up such that we can, you know, solve problems collectively and explore opportunities for us, both for existing companies, new organizations, new nonprofits, and so forth. You know, I'm at Mozilla. We spending a lot of time thinking about this as well, and hopefully in the next couple of weeks you'll see a Mozilla response around this as well. And so that we can sort of keep the open source, open roots of all these things collectively. My many thanks to Hima, Chris, and David for joining. Many thanks to all of you for being with us. We had over 250 people on this call. Again, we're going to make this up on video and send this out around to everybody. And my sincere thanks to our organizing team to working so fast to get us together. We should be, I expect, might have a session as soon as I think next week or week after. With that, take good care, everybody, and we'll be seeing you soon. Bye-bye.